Hello everyone. So in the last video when we were discussing left and right recursion, I mentioned that left recursion isn't too great and I don't want to get into the details of why left recursion isn't very good, but there are some cases where left recursion leads to infinite loops and since we have mentioned that left recursion isn't very good, in this video what we'll do is we'll look at how we can eliminate left recursion from a grammar and it's actually a quite simple method, so this will be a pretty quick video, I hope. So let's say I have the following rules in my grammar. So I have a going to some a alpha 1, a alpha 2 and so on up to some a alpha n, and then I have beta 1, beta 2 and so on up to some beta m, let's say. So what's going on here is I don't really care whether alpha 1, alpha 2, beta 1, beta 2, all of these are terminals or non-terminals. All I care about is that they do not start with a itself. So my beta 1 cannot start with a, it cannot have a left recursion there. So once I have this, what I do is I want to convert this to an equivalent grammar where there is no left recursion, and it's quite simple. What I do is I say a goes to beta 1 and a prime, beta 2 and a prime, and so on up to beta m and a prime. So effectively what I did was I just started from here, this part right here, and I took this entire part and I added another non-terminal after all of my betas. And now since I added a non-terminal, I need to give production rules for that non-terminal as well. So here are the production rules that I give. So I say alpha 1 a prime, alpha 2 a prime, and so on up to alpha n a prime. So as you can see here, this part has a right recursion to it. So there is a right recursion here. What we have done is we've converted a left recursion to a right recursion. What's still left is for me to convince you that these are actually the same languages. So just look at something like a going to a alpha 1. So I have a, and then that generates a alpha 1 from the first grammar, that's the one that I'm using, and then I could have, let's say, another a alpha 1 alpha 1, and that could then yield some beta I alpha 1 alpha 1. So that's what I get from the first grammar. And if I look at the second grammar now, can I get this right here, which is beta I alpha 1 alpha 1? All I have to do to get it is to say that my a first goes to beta I a prime, and then a prime just goes to, let me just do it here. So what I do is I say that I start with an a, and that goes to beta I a prime. So I've gotten the beta I right here. I have this now, and I have an a prime here, and a prime, as you can see, can go to alpha 1 a prime. So I just write alpha 1 a prime here, and the next step what I do is, sorry about that, I should write it like this, beta I alpha 1 a prime, and that can then go to beta I alpha 1 a prime. And at this point what this reminds me is that I'm forgetting one thing that I should add here. That is that I should have an epsilon right here. This is important. So I should have the epsilon right here, which allows me to go to my next step from this right here. So from here I can now go to beta I alpha 1 alpha 1, and this, as you can see, matches what I got right here. So I hope that's enough to convince you that these are actually the same languages. I know it's not exactly a proof, but you can try with a few strings. You'll notice that if you can generate it from the first grammar, you can generate it with the second grammar, and vice versa as well. So it's a pretty simple trick to convert left recursion to right recursion and eliminate left recursion from our grammar. So this will be useful, and we'll get into the details of this when we maybe talk about compilers or something someday. But right now, this is all you need to know: how to eliminate left recursion from our grammar. And I'll see you next time, well, when we look at the grayback normal form, which I've mentioned earlier already. In the meanwhile, don't forget to give this video the thumbs up, share it with your friends so that they can also learn this, and subscribe to my channel if you haven't already. I'll see you next time.